G'day everyone. Thank you all for joining. I think we'll begin now. It's 4 p.m. So a warm welcome to all of you for joining One Stop Warehouse's webinar 1 of 2021. And for those of you who watched the webinar series last year, welcome back. And for the newcomers, thank you for joining and I hope you enjoy it. So today on the agenda is the topic of wafer size changes and the consequential solar panel evolution. Now, this is a very important topic because as we see in history, it repeats itself in the sense that the trend for growing wafer sizes is increasing. So before we begin, let's take a trip down memory lane and look at the history. So in the 80s and 90s, we know that the wafer sizes were around 100 mil in edge length and basically available in 60 and 72 cell format as we see it today. However, towards early 2000s, this increased to 125. And then in 2012 was the size that was introduced, was the mainstream that we had for a long time, which was the M0 wafer type. This was 156 mil, and we see it in many 60 cell and 72 cell format panels. Now, with 156, this was for residential, we got used to around 1.5 to 1.65 or 7 meters long in panel length. However, more recently, we have been introduced from manufacturers, the M6. Now the M6 is 166 millimeters long in edge length. And this has been the mainstream wafer size in all our 60 cell half cut format cell, panels that we distribute at the moment and in the further market. However, we also seen the introduction recently of more larger wafers in the form of M10 and M12, which are 182 and 210 millimeters long, respectively. So guys, that's the background. Now, what's the purpose of this webinar? What's the context? Well, as you all know, being solar professionals, wafers are the central component of a solar system, solar panel, and its design and configuration determine the panel's critical parameters such as dimension, short circuit current, open circuit voltage, efficiency, and many, many more. So we'd like to inform everybody today about the evolution of wafer size in the products we distribute, how wafer size is determined and the technologies behind it, and equip you to be better informed about panels when selecting for your next project or installation. And who better to learn from than the panel suppliers themselves and a couple of industry experts who have direct involvement with this evolution, such as Inverter Manufacturer, GSES, who are professional training, design, and consultancy service company in the solar C&I space primarily. We have GAM Corp, which is a structural certifier and do analysis on solar PV installations on all the roofs in C&I, as well as a professional retailer installation company, Inspire Energy. So as you can see, we have a large range of panelists today, and they'll all be speaking on this topic. And we invited the full spectrum of industry stakeholders, right from the beginning of a solar panel's life, which is Wafer Manufacturer. We have Chief Scientist of Ryzen Energy, Dr. Wan, who's directly involved in the R&D of wafers, right down to the professionals who install these panels on our roof, in the form of Matt Hartney from Inspire Energy, and everything in between. So it is my great honor to welcome our panelists, starting with Jinko. I'd like to introduce Thomas. So Thomas, could you please introduce yourself and give a few words?
Yeah, g'day Ramsey, thanks very much for that. I'll just quickly share across a screen for you there, won't be too long.
Yep.
Okay, so hopefully you can just see. So today the topic is really about the future of solar module sizes and also the technology that you're going to see in the market. So I thought it's really important to just quickly skip through where we are, where we've come from and where we're going to. So the main trend in the last 2 years has been from poly to mono. So in the poly cells, one interesting thing to think about is aesthetics. The cells themselves are quite different colors. So it was reasonably unobvious to the end user or to passers-by if they were looking at a system the colors of the cells. But as we move forward, that deep blackness, if there's any stray from that, that becomes quite obvious. So that's one thing to think about, which maybe is not obvious in this conversation. But the key thing I want to trend there is that shift to the bigger cells, and then what that's going to mean for you guys in terms of current maybe in your systems, or the size of the panels physically when you're planning your trailers, or you're planning something that's going to lift panels onto the roof. And of course, the new technologies, like how do you explain the technologies to your customers? How do you talk about things that you haven't had to talk about before, like perhaps the degradation or LID? These kind of things haven't been an important thing to talk about. It's all just been about energy, but now you've got some other nuances in the discussion. So at Jinko, we think the direction is very much going to be technical improvement, such as for the N-type. And then the other thing will be the size of the cells. We think that 182 is the way to go there. And that's being driven by things like the size of the container, and also being driven by things like the current requirements of the larger inverters in the power plants. So that's just a quick summary there on the types of panels that you're starting to see on the market and the difference in dimension between them. And as we said, we do think that 182 is where it's going to be because of the size of the container dictating what's the best use of space, with freight being really expensive these days. And yeah, and of course, the conversation around warranty and efficiency we think is going to be important. So I hand back to you now, Ramsey. Just if anyone has further questions or dialogue, we'd love to answer that for you.
Cool. Thanks, Thomas. So yeah, basically, guys, we'll do a 2-round process where I'll have my own questions in hand for all the panelists, and then we'll go through each person one by one and do a second round. But yeah, let's just introduce the remaining panelists. So I'll hand it over to Dr. Wan from Ryzen. Could you give a few words, please, Dr. Wan, about yourself?
Thanks, Ramsey. Yeah, nice to meet you guys and so participant here. So I'm working in Ryzen as a head in the R&D department for sale particularly. So as just mentioned, we are going to large wafer size, and that's kind of, I'm involved in this evolution, and Ryzen is one of the company to voice out, 210, the large wafer size. And the very fundamental motivation for this one, for this wafer size, comes from semiconductor. Currently the largest commercialized ingot size for semiconductor is like kind of 12-inch, and that's we came out about 210, the square length, and it's not only just increase the power output because of area. I think the main motivation for that one is the cost reduction, particularly for cell manufacturing. And this we can see kind of like after commercialized or manufacturing for quite a few months in last year and this year, we can see the advantage about like large manufacturing of large wafer or large cells comparing to 158 or 166. We can see quite significant reduction in cell manufacturing, and that can pass the benefit to end users. So yeah, I don't have any PPT here, but just try to say some history about this 210 comes from.
Yeah, cool. Thanks, Dr. Wan. Just being conscious that this is just introduction, guys. So just give your backgrounds and what you do at your respective company. And then we'll start the Q&A session where I'll ask the exact question regarding your specific topics. So passing it on to Manfred, please, from Canadian Solar.
Thank you, Ramsey. Thank you for having us there at One Stop Warehouse. I'm Manfred from Canadian Solar. I'm the sales and key account manager. I predominantly focus on utility scale. There's all your solar farms, hundreds of megawatts, but also in the C&I space, because the technology goes hand in hand with what you develop, and it reaches down to the residential install as well. We do look after racking systems, inverters, and full turnkey, mainly on the large scale, but we bring this down to what you present here today and all the panelists as well. Thank you for having me.
Thanks, Manfred. And now to Dean from Goodwe.
Thanks, Ramsey, for having us. So my name's Dean, looking after the sales and the distribution in the role of country manager for Goodway Australia. We specialise in manufacturing inverters for the residential, commercial segment, and also about to get into offering batteries into the Australian market as well. Thanks, Ramsey.
Thanks, Dean. Always a pleasure. And moving it on to Julian from GSES.
G'day, Ramsey. G'day all. Thank you. Yeah, so at GSES, we are a trainer, a consultant, and an inspector. So we get to see a really broad spectrum of the industry. We have people come through and they get their first real hands-on experience with solar panels when they're doing their CSE accreditation. Where I'm in the service delivery side of our design team. So we see our ex-students who've gone out into the workforce, and we help them with design as they grow their businesses. And that's a really interesting way of interacting with industry and seeing what our students are now doing and what they're up to and how we can keep helping them. And then we see a lot of stuff on our inspection side, which also helps to inform what needs to change in training. So I like to think that we get a very unique window on and view onto all of the industry there.
Thanks, Julian. And just for information, guys, we recently partnered with GSES as our partner. So a little bit about GSES, they actually specialize, as Julian said, in training, design, and consultancy. And they have close ties with UNSW directly. So they have basically, good friends with the pioneers of photovoltaic space. So if you need any support in your projects or you have any questions regarding your solar installations, feel free to contact GSES. They're always happy to help. And on that note, next I'd like to present Sana from GAMCorp.
Afternoon, everybody. Thank you, Ramsey. Thanks for having us. One Stop. My name's Sana. I'm in the project coordination team at GAMCorp. I'm the manager there, and it's a really interesting topic today. I'm looking forward to having a chat with everyone here about it. Encourage everyone to leave some questions. We're based in Melbourne, and we do the structural engineering components of your larger commercial installations. So if you have any structural engineering concerns about the integrity of the building, or any requirements that might be required, uniquely for that array frame or any kind of steel structure to support something, we are the designers of getting people out of trouble when the buildings aren't working too well. So, and if you ever come up with that situation, I hope you don't, but if you do, give me a call.
Thanks, Sana. Always a pleasure to have you. And last but not least, we have Matt Hartney from Inspire Energy.
Hi, Ramsey. Thanks for having us in One Stop. Yeah, I did my GSES course actually in solar in 2007. And yeah, so we did our course then, and we've been installing residential and small commercial up to a megawatt since 2008. Yeah, so we've seen sort of all the panels from 1 to 5 watt panels up to, I think we just finished a job today with the 500 watt panels. So bit of a difference.
Awesome. Well, really happy to have you on the show, on the webinar, and really keen for the discussion we're going to discuss now. So guys, I'll hand it back over to Thomas, and I'll relay my first question towards him. So Thomas.
Yes, Ramsey.
You are one of the first to release the 182mm wafer, the M10, to the market in the form of your new range of Resi and CNI panels. So my question is, why is this new larger wafer specifically 182? Who else is using this size, and what kind of panels are released with this? Like, what are the pros and cons you'd say for this 182?
Hi, Ramsey. So a lot of the developments in solar are driven by the utility sector, and the utility sector is facing increased freight costs. So the 182mm cell is one way to maximize the density of modules within the containers that we use for sea freight. And the 182mm format has been adopted by most of the large manufacturers, not everyone, but for example, Longi and Jinko are focusing strongly on that technology. And in terms of the cell markets, that's going to feed through to what modules are available. It's going to feed through to the price points on modules. That's expected to be the dominant cell class within the next 2 years. And your second question again, Ramsey, if I could have that.
Yeah, so as discussed at the introduction of this webinar, the main wafer sizes between 2010 and 20 were the M2, which is 156.75, and of course the 166 millimeter M6. However, you released the mighty Tiger N-type 390 watt panel exclusively with us as well, in the unique size of 163.75. So what prompted this unique and exclusive wafer size?
Yeah, so with the N-type, what we're looking for there is a way to provide a low-cost N-type panel to the market that still gives you all those quality and reliability benefits of N. And so we wanted to use the existing equipment that makes modules to bring that N-type product to market and basically do it in a sustainable way, an environmentally conscious way. That means we're not throwing away production lines, we're able to reuse that stuff. So for that reason, we've put that smaller cell size on the N-type because it's primarily going to residential and small commercial.
Yeah, cool. All right, now let's jump to Ryzen with Dr. Wan. Thank you, Thomas. So Dr. Wan, in your case, you're one of the first to release the 210 millimeter wafer in this case for the solar industry. So why have you selected the 210 size?
Oh, hi, Ramsey. Yeah, sorry, as I mentioned in my introduction part, yes, I mentioned kind of this history about the 210 wafer size. So from our side, because like at Ryzen, we don't have the ingot, this sector, we do in sales and then modules to the end user. So to us, we are trying to, like, say, what's the maximum possible size in wafer ingot from semiconductor. And that also, the wafer size, like about 210 has been kind of discussed in academic for quite a long time. I think since like 2009, like lots of conference in like IEEE or EU PV SEC. So we, like every year we have this kind of discussion, and possible. The topic is what's the largest size of the sales will go, and every year, so the possible maximum one comes from semiconductor 12-inch. And that means it's 300 millimeter in diameter, and that will come around 210 or 22 or something in the wafer length. And and then come to like last year or end of 2019, one of the wafer supplier, they really did this business. Provided large wafer to the cell manufacturer like Ryzen or other companies. So I think for Ryzen it's very good chance to chip into this wafer size and can take advantage of the cost associated with the large wafer manufacturing. Yeah.
Cool.
Yeah, that's kind of our consideration in the liberation. Yeah.
Yeah. So I gathered so far that the 210 millimeter is mainly influenced by the semiconductor industry, and with also manufacturing costs taking into account. So, but from a scientist perspective, is there pros and cons with the larger 210 compared to the previous generation wafer size in the context of solar panels?
To us, for the large wafer, the main advantage is kind of cost reduction in manufacturing, particularly cell manufacturing. And then if you say about the drawback part is most of the current facility or equipment, they are not able or not compatible with this large wafer manufacturing. So basically what we did is to build up a new fab for both cell and the module. And this, like for Ryzen, we don't have very high, manufacturing capacity in last few years. Like what we have, like 5 gigawatts in monocrystalline cell fabrication and like less than 10 gigawatts in modules. So for us, we will have expansion, and it's just a topic of what kind of technology we need to go and what kind of wafer size we will choose. So to us, we will build up new fab and then go for the large wafer size with a low cost and also with possible, I mean, for new equipment, the largest we can go. So that's what I'm thinking right now. Yeah.
Yeah. Okay. So understood. So driven by wafer size increase, driven by manufacturing economics, by semiconductor industry, and also, as Manfred also touched on earlier, catering for utilities primarily. So I think, in my opinion, that it's up to manufacturers to optimize these, optimize integrating these cells into residential friendly panel dimension. So on that note, at Ryzen at the moment, is there any current R&D looking into increasing the efficiency of the cell or the wafer? Currently, we've been seeing mono-PERC dominate for the last few years. Is there anything in the works that we could expect very soon to commercialize?
Yes, definitely. I mean, for the efficiency of cell efficiency improvement, we are working on like what most of companies are doing to the persuading contact to introduce persuading contact, improve efficiency, and go for N-type to improve the bulk lifetime quality. And all this one can be integrated with a large wafer size 210. And so that's like when we build up the new fab for right now, the PERC cell manufacturing lines, we actually quite a few companies, they have already considered how to be compatible with the persuading contact technology or N-type technology. And that's one thing right now we are doing at Ryzen. And another one definitely is Ryzen has been the junction or HJT cells. But at this stage, we are still go for like a 158 wafer size or go slightly bigger. And we are also working on with the equipment supplier how to manufacture like HJT cells at large wafer size like 210 wafer size, and that definitely needs quite a lot of work in equipment processing wise.
Okay, understood. Cool. Thank you, Dr. Wan.
Thanks.
So now, before I move on to Manfred from Canadian, I want to just open it to the attendees. So feel free to ask any questions you might have, and we'll be answering them. So if you have any questions, feel free to ask. Now we'll move to Manfred from Canadian Solar. Manfred, Canadian Solar, I also recently heard you guys added the 210 wafer size to your product roadmap as well. So which products is using this 210, and what's your reason for using it?
Thank you for the question, an excellent question. Just adding, we have heard a lot now from the previous speakers. The 210 is a format that's being pushed forward. In this case, Canadian Solar was not the first, but we watched the market. But more importantly, we've worked for quite a few years with our customers from the solar farms utility, again, hundreds of megawatts ground mount, single axis tracking, CNI space, and residential to get the feedback, not just to be scientific driven, cost driven, because we all heard it now many times. Cost is very important. Then yield is very important. The two factors give you for your return on your investment on any system, but handling is super critical. So we all have heard of the better mousetrap that no one wanted. If the scientists and engineers get free rein, we would have a multitude of products no one really wants or appreciates. They may be 10 years ahead of time. They may just be not what people want. Canadian Solar was the first one to really introduce into the market, be brave enough to split cell. And there's something that hasn't been mentioned here yet, but this whole 182 210 mil, all those modules are only really feasible with a split cell technology. And I remember it's not long ago, and you all from the installer point of view, you looked at those modules, go like, what is this? A half cut cell, half a cell. Why don't we have the big cells anymore? Now, no one's shipping full cells anymore. The advantages are very clear because you could design a module that has a better performance, a lower cost, a higher reliability, and you all of a sudden had a chance to create different formats. You weren't restricted to the 60 and 120 cells. You halved your, or 72, sorry, you halved your cells. You could play around with rows. And going now to the new 210 cell modules, Canadian Solar, we look at the same way. The largest modules, 660 watt and more coming, were really designed in reverse. I mean, you may laugh about this, I have done installer training with just timber modules, not even real modules, because it doesn't need to be a module and people break them. But we want to see how do people handle them? How do you carry it? How do you move it? And these modules, 660 watts, 665 watts, they're really big. We're now talking almost 2.4 meters by 1.3. If you go to your hardware store and you say, I like a 12 mil plywood sheet, that's pretty much what you're looking at. So give me your feedback if you want to put it on your roof. If you think residential 6.6 kilowatt with 10 modules would be ideal, reach out to us and we'll make it work for you. But you see, it's really driven from Canadian Solar's point of view. We have people all around Australia. I'm in Sydney, we have Melbourne, Brisbane, but we get the feedback from all our installers, third-party installers say, what helps you to save? Module cost is one part, but module cost has come down so much. You all remember like $1.20. Now I'm talking Australian dollars per watt, coming down sort of to the 60s, which seemed really low. And now we're well and truly in the 30s and we were below, but as we all know, it's going up again a bit. I'll touch on one point as well, shipping. And shipping is really a major, major cost, again, utility. All this 210 cell wafer, split cell, it's all driven by utility scale. When you ship hundreds of megawatts, all of a sudden you have 1,200 containers to worry about. You're shipping 20 containers a day. You want to cram as much as possible. Just a few years ago, we put about 200 kilowatts in containers. Now we put 350, 360. We played around with 380, but the savings we had there, we found from the feedback, our customers, they said it's taking us now double the time to unload because there's now that much room on top of the modules and the weights are just too high. So we backed off a little bit. We invented a novel way to package, very different. And with the first deliveries, you will see. But so it was a simple question you asked. Why do we go there? Utility driven, 660, 670 watts. It was just not possible to go with 166 millimeters or even 182. There is many technical limitations, in particular the voltage. You want to be able to maximize the 1,500 volts you're allowed in a system. Again, on your rooftop, you never get there. CNI, it may be of interest, but with the smaller wafers, you just had too high a voltage. Now the currents go up, but we redesigned those as well, and we're working as we speak with residential and commercial installers. And hopefully towards the end of the year, we can reveal scaled down modules on this technology for your rooftop. But we still need to get a lot of input. What are you willing to handle? I remember when we introduced the Haiku series with 1048 width, everyone says never going to sell in Australia, ever, because the mounting rails on the roof just didn't come standard in the length you needed. Guess what? Now the standard mounting length fits 1048. So we take a bit of risk, but we need all your input. I hope I didn't overdo it here. Feel free to ask more questions.
No, Manfred, that's perfect. Thank you for that. And okay, also, we all know CSI, nicknamed or Canadian Solar, one of the experts in polycrystalline. And to this day, we actually distribute polycrystalline models from them. So being experts in this technology, I know it's pretty much taken over by mono, but will there be ever a return of poly cells for the larger wafers, such as the 210?
Thank you. That's a very beautiful question. And thank you for highlighting our love to poly. Will there be a return? right now, this week is the return, and the main reason is cost has gone up again so significantly that the poly savings on modules is significant enough, especially in the residential install. It does just make the install cost that much more positive compared to the mono. And at the moment, we're seeing very big demand on those smaller 350, 360 watts or the 420 watts, the haiku, depends what people want to handle. Very big demand. Long run, will we see 500-600 watts in poly? Very unlikely, because the main driver for these 210 cell wafers and the format was to get as much power per handling unit as possible. If you think utility scale, you don't have a simple racking system. You need piles. They go really deep in the ground. You have torque tubes. You have tons and tons of steel. And you want to maximize the power per dollar spent on this steel. If we go to poly, yes, we save on the module, but module cost is now so low in the entire build. The percentage of module cost is now so small that the poly doesn't really bring those significant savings anymore. So no, they're highly unlikely to see poly in utility scale in those large 500-600 watt formats. But poly seems to be very resilient and has sort of resurgence in the residential and C&I space.
Awesome, Manfred. Thank you. So that tops off the panel suppliers for now. So now we'll move on to the inverter manufacturer. In this case, it is GoodWe, and we have Dean representing them. So Dean, it's no surprise that as the wafer evolves to become larger and larger, the current also is increasing, the ISC. And of course, manufacturers are doing a good job of minimizing this increase with their technologies, but it's still increasing nevertheless. And how will you guys cope going forward with your product roadmap? And will it be safe to use your products on the panels with very high short circuit currents?
Thanks, Ramsey, and good question. So it certainly does have implications as an inverter manufacturer. So as we've seen the panel and the wafer sizes increase over the years, it means that as an inverter manufacturer, we've constantly got to be upgrading our inverters to be able to accommodate those higher currents. And when we're talking about upgrading, we're talking in particular about the maximum input current of the inverter. So I'll just share my screen with you. And a question we quite often get asked is, what happens if the current is greater than the maximum input current of the inverter? Some people ask whether the inverter will fail or whether it potentially generates less. The answer is that it's not going to fail, certainly not initially, but what you will experience is what we call clipping or loss of generation. So if you take our DNS, let's say 5 kilowatt inverter, for example, that has a maximum input current limit of 11 amps. If we're talking about some of the new panels or wafers going into the market, essentially you're looking at about 13 amps. So what actually happens is that you will lose generation. So when we're talking about clipping, it's loss of generation. And what you will do is you'll lose the difference between the 13 amps and the 11 amps. So the power beyond the 11 amps is actually abandoned. Now, another important topic is that when you are actually overloading these, some of the key componentry will potentially get hot or run over the temperature rating. So whenever we're talking about a maximum input current, it's always the maximum input current as long as you can maintain your temperature rating. So, so from a GoodWe perspective, we're currently upgrading most of our products at the moment. I'll just go on to the next slide. So we believe that moving forward, and especially over the next few years, that a maximum input current limit of 15 amps should be sufficient to accommodate for most of the panels moving forward. Now, it's not always as easy as just jumping from the input current limit you have right now to 15 amps, because you've got to be able to do that. You can only do that if the design of your current platform can maintain its temperature rating. So just to give you an idea, the current DNS model that we have at the moment, we're in the process right now of moving from 11 to 13 amps. We think that 13 amps we'll probably be able to handle 95% of the panels or the wafers within the next 12 months. But because the current model didn't have the design to accommodate 15 amps, we're currently in the process of developing a new generation as well, which we're calling the DNS2, and that will have a 15 amp current input. So that one will release in January 2022, but at the moment we're in the transition phase and we will be able to move to 13 amps within the next month or two. For our three-phase inverter, for the 5 and the 6 kilowatt, we'll move from 12.5 to 15 amps. That'll happen in the middle of the year. And then we're also releasing an 8 to 20 kilowatt range as well at the same time, which will immediately come with a 15 amp input limit. And then the SMT around Q3 or Q4 will also move to that 15 amp limit. So we certainly see the trend in the market. We do believe it'll stabilize probably within the next 12 months or so. And from our point of view, we think 15 amps is that limit. Now, I suppose another question is, what happens if someone does overload it with 13 amps if they've only got 11? You know, will that impact the warranty of the product? Potentially it will. But to be honest, it's probably not something that the guys working out on service are either asking, or unless someone actually goes to site to actually diagnose and find out that that's happening, it won't impact the warranty. But generally speaking, the inverter's not going to fail. You're just going to experience some loss of generation, but potentially in the long run, it can reduce the lifespan of the inverters because the components can get hotter. And as we know, with all electronic equipment, the number one source of failure is heat. So yeah, thanks, Ramsey.
Yeah, thanks, Dean. Thanks for updating us with your product roadmap and giving us some insight into this current topic. And now we'll move to Julian Sterling from GSES. Could you, Julian, could you give us your thoughts on this Wafer evolution? As being a solar trainer and consultant provider, what experiences have you had given these changes and hearing what the panel manufacturers are saying?
Yeah, so as I said earlier on, we sit in a very, I'm just sharing a screen and I hope that's working.
Yep.
I'll assume that you can see it, and if you can't, we'll just go on without it. As I mentioned earlier, we sit in a very unique position between customers where we're seeing people be trained, we're seeing people do their installs, we're helping with installs, and then we're inspecting. When we train, we're training all with a residential mindset for our new installers. So that's all done on 60-cell modules, and traditionally they have been smaller. We're seeing that these are starting to grow now, and we're starting to have to accommodate training for larger modules to make sure our courses still carry that reality through and people are prepared for the real world. So that goes through to things like manual handling, that goes through to things like lifting, that goes through to things like planning a lift onto the roof and even getting your modules on site. A few weeks ago, Thomas, you mentioned a great point about the size of a van or the size of a trailer and how that impacts somebody's business. So there's all these electrical impacts that we're seeing in solar system design from these increased wafer sizes, but that flows on to so many other parts of the supply chain and parts of the process of installing these systems. All of these things have a huge impact, and where we see it as well then from our after the training side is where it flows through to system design. People have a bit of a short-term memory, and they're able to remember systems that they were designing almost without thinking. Each time they would do the same system. And as we see panels get larger, as we see currents get larger, we're seeing that people are forgetting to say, hang on, does this array still match with this inverter? So inverters are, again, being put out. As we just heard from Dean, inverters are coming out with an increased maximum current input. But if somebody hasn't considered that they might need a new inverter to go with a new, larger panel, we're seeing all of those things be forgotten and we're seeing bad designs happen. So where we sit is trying to be very careful about remembering that change in design. We're seeing a whole lot more current happen, current out of these panels, and that means cables are derating faster, and people need to be prepared for that. Some people used to cram as much cable as they could into a tray and put a lid on it and walk away and never think about it again. But now that can't be happening, because very quickly we're increasing, and we're seeing that some systems just don't even work with 4 mil cable. You're on 6 mil cable as soon as you even start designing with some modules. So all of these things at every point of the design need to be considered. And we're hoping that where we can help out is sitting there alongside designers and making sure that they're getting it all thought out at the start. Ramsey, I think you're still on mute there.
Oh, sorry guys. So thanks, Julian. Interesting perspective. And yeah, I agree with you. I think it travels more than just the electrical parameter side of things, and travels down to all the different processes involved. So thanks for that. Good points. And I think we'll move to Sana now for GamCorp. Sana, you know, panels, our mounting certificates, our structural analysis guide, engineering reports for our mounting cater for, you know, up to 2 meters, 2.2 meters panels. But now I think with these larger 210, 72 cell format panels, they'll go beyond 2.2. So have you guys, you know, worked on this, or what's the status with you guys?
Yeah, absolutely. I didn't prepare these slides for this question, but I just happen to have them on hand either way. No, just kidding around. It is a serious problem from a structural engineering point of view, right? These panels are getting bigger and bigger and bigger. And the main concern is because these buildings, I should say, are designed for a uniformly distributed wind load, which effectively means as an engineer is initially designing the building, they're saying, oh, wind's going to hit that on, you know, in different directions and pretty uniformly across the whole building. Now, the problem is that when you start putting panels down and they have clamps and rails and whatever else there is, these large areas now are point loads that are hitting the major structure of the roof area. Now, as it's doing that, the whole way the building is being forced down and the wind pressures acting on that roof is now completely different to what it was designed for. And although it's really good from an energy point of view that, you know, we're getting larger panels and everything like that, and we want to encourage the growth of the industry, we just want to also make sure that everyone understands there are negatives to that as well, which is what it does to the structure. So the importance on, you know, getting any structural engineer that's, you know, close to the site or has the ability to get to the site, to have a look at the site, say, okay, if I'm putting these larger panels on a building, even if you've been doing this for 10 years, you know, these are things that haven't been around in the last 10 years. So it acts differently to how the building and how the panels actually interact with the building. Lastly, I'll put as well as the bigger issue next to that, Ramsey, is as we get bigger panels, we also get bigger weights. We get heavier panels per square meter. You get more surface area of the whole panel. You know, if we're doing north face installation, as I'm sure everyone loves to do, to, you know, accommodate for that sun, the return of that is that, you know, if we're looking at a portal frame, which is this orange line, and this is a deflection line in blue, which is quite exaggerated. If we start putting these larger panels along one side of the face, you're ruining the whole integrity of the building, which is its shape, this triangular kind of base shape. So they're the main two concerns. And this applies also to pallet loads, right? We're dropping pallets that are now heavier than ever on roofs and everything. So being really considerate about how, you know, these bigger, larger wafers, which would effectively mean larger potentially panels, you know, how it interacts with the building can be a huge concern for most structural engineers within this industry.
Yeah, cool. So I think it's important now more than ever, guys, and I'm talking to you panel suppliers, to find ways to increase the efficiency, okay? All right, thanks, Sana, for that. Appreciate your explanation. Now, finally, we have arrived to Matt. So Matt, you guys are very experienced in the resi space. You've installed countless 6.6 kilowatt systems. But not only that, I think you've installed a lot of CNI and a couple of megawatt projects. So given your pedigree and experience, so could you give us your feedback on what you've experienced over the years and what's your thoughts on these new wafer sizes that's coming out.
Yeah, so from an installer's perspective, one of the major points with the panels getting bigger is just around the design of the system. Sort of to touch on some of the things covered before, the higher currents, it does play a factor in the system design, especially around cable sizing, and especially on a residential system, there was a lot of, it was quite cookie cutter. You knew you just had to run your one cable to the roof, and you could maximize the panels. Whereas now you have to take into consideration, if you're going to dual string a panel that's no longer 18 amps, that can be up to 26 amps. So you're doubling your cabling requirements for those. And we find a lot, especially with our residential teams, is transporting the modules. They no longer fit in a normal sort of 6x5 trailer. That it's not a big consideration for a C&I space, but for a residential installation, those trailer sizes have to grow. So transportation becomes a bit of an issue.
Yeah, cool.
And then also similar to what with GamCorp is with larger panels, especially on, say, for a tin residential roof, sometimes your battens are only a meter apart. So to try and get those point loads in, you either have to landscape mount the modules, or you have to have a 3-rail system, which is quite common on commercial, but on residential that was never a consideration. Whereas now with a larger panel sizing, that's starting to become a bit of a consideration as well.
What's the sweet spot for, like, let's say a typical tile roof home for a single story or double story family home?
Sorry, I missed that. What was that?
What's the sweet spot for panel length for like a tile roof house, you'd say?
So the 1680 panels used to work perfectly for most tile roof houses, that you could have a double array. Now you'll find if they're above that 1680, which most modules are, they're all around the 1750 to 1800 now. It's sometimes difficult to get a dual row of panels on a single story residential property.
Yeah.
Which affects your design.
Mm-hmm. Okay, cool. And so the newer panels, as you said, they're around 1700 to 1850. So are you having to, install your panels on different roof faces because of that, or you still finding shorter panels, or what's the scenario?
Yeah, so now obviously you try and factor your design into having single rows as much as possible, which does mean a lot of east-west arrangements as opposed to just your ideal, which was just north-facing roofs all the time.
Yeah, cool.
Yep.
All right. That's all the primary questions I had, guys. Anybody in the attendees have any questions? I'm checking now. All right. Looks like there's no questions currently posted. Does anybody else have anything to add? Any panelists?
I'd be interested to hear what the manufacturers say on pushes for standardization of wafer sizes. Is that something that you're all keen to move on, or do you each have your own niche and your own particular advantage in producing what you're good at?
Yeah, so I think I'll go one by one. Probably start with Manfred, since you're very keen with the mute button.
Was a bit too quick. Thank you very much. That's an excellent question there. We have seen in the past there is an attempt to standardize because it helps the supply chain. And when you think back, there was a few gigawatts produced. Now everyone's producing tens of gigawatts, and the global demand for this year is going to end up anywhere sort of from 160 to 200 gigawatts. It's a very, very big number, big units. Standardization's difficult because it's still a very young industry. However, we can see the demands coming from the different customer groups, and the volumes help to shape what will be successful. At the moment, it really looks like that for the medium term, at least, the 210 sizing is the kind of a common understanding this will be around for a long time.
Cool. Thomas, your thoughts?
Yeah, thanks, Ramsey. I didn't hear clearly then, so I assume you said Thomas, but I'm not sure. Yeah, so just with respect to the standardization, as was mentioned there by Manfred, some of the manufacturers that are quite large, for example, Jinko can do the 163 on the N-type just because we are of that scale. So the smaller manufacturers, they will still have to tack in with what the big guys are doing. But those of us that are quite large, yes, we now do have that gigawatt scale that it sort of doesn't matter what the market's doing. Having said that, in the project space, the people like Nextracker that develop the large racking systems, they do look for that from the market to provide a standardized product. And we think that 182 and 210 will be the mainstay for that part of the market. Now, in terms of the small modules that would suit people like Matt, that are installing maybe a residential job, it's up to you guys to buy it. So if you buy the panels, they'll be there. If you don't support the smaller modules, they'll disappear from the market. So we do hear a lot of installers saying, oh, I'm sick of these panels getting bigger. The next minute they say, I've just installed the job with a 500 watt panel. So as soon as that's the direction that you take your dollars, that's where the products will go. So if everyone's buying a 315 panel in a small format, we'll keep having that. If you guys support the smaller formats, they'll be available. But if more and more of your friends start moving away, if the conversation goes that way, then you won't see that small product in the market, and it will go to a standard, and it will be based around the 210s and the 182s.
One, your thoughts on the standardization?
Yeah, that's a very good question. Actually, the industry actually is working on this one. A lot of companies are discussing. They have discussion lots of different place, different time. I mean, to me, just very personal perspective is still like in last 10 years, it's the same discussion happening in academic. It's what's the largest wafer size we will go for cell manufacturing. To me, it still comes to the semiconductor. That's kind of a limit. We are kind of extension from semiconductor. And so far, I think in a medium time or sometime, the wafer size will stop at somewhere like 2110 around. And if you say, can we go, I mean, go further? So far I didn't see any strong motivation for this one. Particular reason is the large wafer or ingot growth from semiconductor is still on the R&D. Like a 450 meter diameter is definitely still on the R&D stage in semiconductor. So yeah, my personal perspective thinking is we'll stop somewhere for some time, like 210 or wafer size. Yeah.
Okay, so given Jinko has selected 182 as their optimized size and yourself and Canadian venturing 210, I'm guessing 210 is pretty much the cap, the largest size we can physically, commercially be viable for a while. So I'm guessing now is the time to increase the efficiency of the cells. So would you say this is correct? Are we in the period of stop increasing wafer size and more R&D investment in efficiency? Manfred.
Jump in again.
Okay, go for it.
So I'm actually also a scientist by background. Going back to the 90s at University of New South Wales, my colleagues Aiwa and Zhao already produced PERC cells, which we now all use, with 24.2% efficiency. This was in the 90s.
Wow.
Why did it take so long to find its way into your trailer and onto roofs? The cost was just prohibitive. And as I said, 160 gigawatts, but even if we break it down, I don't know, you installers, how many jobs do you do a week? You couldn't do so many jobs if the cost was still so high. A main driver is bringing down the cost. Wafer sizing is predominantly the cost. And these handling units driven by utility scale to say we want more watts per handling unit and tracker drive motor. Efficiency, if we stay with silicon, so the main predominant material we all use in the solar cells, silicon does have a physical limit of just over 30%. It's just physics, has to do with quantum stuff. Call me and I'll talk hours to you about it. but you can just go about 31% efficiency maximum. That's theoretical. And with about 24, 25% cell efficiency, translating to now in our new modules, 21, 22% efficiency, even if we go to N-type, the limits still apply, you squeezed out pretty much the maximum. Now, the next step, and the focus is there. I mean, we're focusing on heterojunction for premium markets where space is expensive. Japan will be the starters. These modules are coming. And you heard it there from others as well, that they're working on higher power modules, but they will be expensive. And I loved it before what was said. If the installers want it, and if they buy it, if One Stop orders more and more of it from us, you will see it more on the shop floor. But for now, we're going to stick with 210 for quite some time. You're probably going to stick with the 21% efficiency for some time. The next step is possible. It's been possible for a long time, but a bit costly to go to 25, 26% efficiency.
Yeah, cool, Manfred. Okay, understood. All right, I have been conscious of the 1 hour time schedule. I have one more questions for panel suppliers. Does the panel manufacturers look at expanding the clamping zone, given residential rooftops, limited space, and even the modern tin interface roof on housing with, I've seen the common scenario of the 900 mil spacing between the screw lines. So when the panel is bigger, it's very hard to meet the clamping zone of the panel manufacturer. And are you guys taking this into consideration in Resi? And are you going to increase your clamping zone tolerance zones? I'll start with Thomas this time.
Yeah, thanks, Ramsey. So depending on where you are in Australia, the pressure that you're likely to face on your site will be different. The majority of the population is in wind region A and wind region B. And we do have extra support in those areas in terms of flexibility for clamping zones. The other thing that we are doing at Jinko is we will be bringing in a 54 cell panel that will have a shorter length. And obviously the N-type panels do offer slightly better compatibility with the roof framing. And I think you'll see that some of the structures will also be enhanced. So I think it was mentioned there by Sana, and also I think even Matt had mentioned some railing systems use 3 rails now. So you might see some innovative railing designs that give a better performance in terms of even support for the modules, which we're starting to see that in Northern Territory and some other regions where they're using 3 rails. And that does give us a little bit better use of the spacing that is there already in the roof. Also, we're seeing architects now coming to us and saying, what's the placement of timber that we're going to need in modules over the next 6 months? So that's an interesting development.
Cool, Thomas. Dr. Wan, would you like to add anything to clamping zones, or leave this to Brian?
So yeah, maybe I'm not the expertise in this area.
Yeah, sure.
Steve, to others, yeah.
Yeah, Manfred, anything to add for clamping zone?
Thomas answered that very comprehensively. Thank you, Thomas. It's as he says, the wind regions are A and B. The modules, I mean, we have the high-Q module that has clamping zones the same, and it still works, but it depends on those rows that Matt said before as well, 1 row, 2 row installs. It will grow. The new modules, we're looking at it because they're heavier. We're looking at the roof pitches as well. We're still gathering the information from the market. I don't have anything else. Sorry.
Okay, understood. All right, guys, I think that will conclude our webinar session today. So thank you all to the attendees for joining today. I appreciate you making time. And as all the suppliers and panelists just mentioned, it's because of you guys is what determines the products that are coming into the market. So thanks for your continual feedback and your loyalty and investment into your projects and company. I hope you learned something more about panels today and the wafers, and are more informed for your next purchase. And One Stop Warehouse, we take the customer feedback very seriously and always relay it back to manufacturers to ensure that the next generation or iteration of products are suiting your projects much better. And yeah, we're very excited because, as you just heard, N-type is increasing technology is on the hunt for increasing efficiency, and you know, everybody's responding positively. Inverter manufacturers are ensuring their inverters will be capable, and yeah, so thanks again, once again, for everybody. And before I close off the webinar session, I just wanted to share my screen to show you something. Basically, on the 4th of May, we'll be running webinar 2, and that time we'll be speaking about the new standards. So the new standards relevant to us, of course, is AS4777 and AS5033. So the inverter standard and the solar PV, more broadly speaking, standard for DC side. Yeah, the 2020 published version of 4777 is out, and it's going to be into effect at the end of this year. So we'd like to gather some inverter manufacturers to speak about it and better inform you to be prepared for this transition phase, as well as AS5033. There's quite a new array of significant changes which needs to be discussed. So if you're interested, I'll put the information on the screen right now. And you can register on any of our social media platforms, LinkedIn, Facebook, and YouTube, or our website. So this is just a banner. And 4th of May, 1 p.m. via Zoom, like today. So go on, register, and you will be much better informed about these new standards, because it affects everybody. You know, distributors, manufacturers, installers. So it will be one to not miss. Once again, to my fellow panelists, thank you guys so much for joining and taking time out of your days. Really appreciate it. And it's always a pleasure.
Thank you.
Everybody. Thanks, everybody.
Thanks, everyone.
That's fine.
Thank you. Cheers,
Cheers,
guys.
guys.